All right, students, so we are on section 10.5. We're picking up with example 4. All right, so example 4. And now they're going to change the, kind of the parameters of what you're factoring. Now they're saying factor when B is positive and C is negative, but the thought process is still the same. All right, so now we have this. Okay, you're still looking at the last factor. It's negative 18. So you're looking for the factors of negative 18 that are going to combine into positive 17. So that's telling you you're going to have a negative and a positive factor to get to negative 18, but that when you put them together, the absolute value of the positive factor is going to be larger than the absolute value of the negative factor because this middle term is going to be plus. All right, so we'll say, so this time we're going to put the smaller factors on the left. We'll put the larger factors on the right. We know these are going to be positive. We know these are going to be negative. All right, so let's look at factors of negative 18. Well, we got 1 and we got 18, right? What does that combine into? Oh, there it is. That combines into positive 17. There it is. So here's our factoring for this. X minus 1 times x plus 18. Okay, you could have had negative 2 and positive 9, but what does that combine into? Positive 7. So that's not going to be it. So once you hit the one combination, that is it. Okay, you're done. All right, so let's do the checkpoint now for 13 through 16. Why don't you hit pause on this and then come back. Okay, and I'm going to clear this. Okay, all right, so checkpoint. So if you're back here, you have already worked through them and you're just going to watch what I did here to check yours. All right, 13 x squared plus x minus 6. Okay, so I'm looking for factors of negative 6 that are going to combine into positive 1, right? This coefficient is 1. So I want my larger factors to be positive. I want my smaller factors, absolute values of those factors, I guess I should say, to be negative. So, all right, let's start with 1 and 6. What does that combine into? Well, that combines into positive 5. So that's not going to do it, right? And then I'm going to have negative 2 and positive 3. Wait a minute. Okay, this could work, right? Because negative 2 plus 3 is going to give me that positive 1. And it multiplies into negative 6. So that is my factoring. So it's going to be x minus 2 times x plus 3. Okay. All right, number 14. X squared plus 2x minus 8. All right, I need factors of negative 8 that are going to combine into positive 2. My absolute value of my negative factors will be smaller than the absolute value of my positive factors. So I'm going to put 1 and 8. What does that combine into? Oh, that combines into 7, so that's still not what I need. The next one's going to be negative 2 and positive 4. Okay, that multiplies into negative 8 and combines into positive 2. So this is the combination I want. So this is going to factor into x minus 2 times x plus 4. Okay, number 15. X squared plus 8x minus 20. All right, so I want factors of negative 20 that are going to combine into positive 8. So my left side, which is the absolute, going to have smaller absolute values than my right side. So I'm going to have a positive and a negative. I do 1 and 20. What does that combine into? Well, that combines into 19. That's not going to do it. Then I'm going to do negative 2 and positive 10. All right, here we go. This combination is what's going to work. Okay, so this factor is x minus 2 times x plus 10. All right, now let's look at example 5. They're saying here that you can use a graphing calculator, okay, to help you factor something. And that can work if it's, if it cuts through the graph really nicely. So they're saying, okay, factor this. Factor x squared minus 2x minus 8 using your calculator. They're saying, well, you know that x something times x something, right, is going to be what you're going to factor. And now what you're going to do is you're going to look and you're going to put this in the calculator, okay? And what you're going to see is that you're going to see that you're crossing, and I'm just, okay, it looks like you're crossing here, okay, I'm just looking at the graph here. If you look at, put this in your calculator yourself and you'll see it too. And it looks like you're crossing here, and so it's doing this, okay. So what does the x equal here? Well, x equals -1 here, and what does x equal here? Oh, wait a minute, what did they do? They said 2 and -4. Oh, you know what? They're scaling the numbers there. Okay, so technically speaking, it's actually going to look like, well, they're saying each of these is 2, I think. So this is 4, and this is really -2. Okay, that's a little misleading the way they're doing that. If you did this on your calculator, what you're really going to graph is this: y equals this, and you're going to hit zoom standard, and you're going to look and see where you're crossing the x-axis. All right, so they're saying you're crossing here at x equal -2 and x equal 4. All right, so what that really means is you always put kind of a minus here, okay, and then you're going to put in what you see here. So it's minus a -2, okay, and then minus +4. And there's a reason for that, okay? But this ends up being the factoring for this because you're actually going to hit what x equals when you're hitting when y is 0, and so that's why it's the opposite sign of what you think it would be. I don't know if this is very helpful, but that's kind of what you're doing. So you can look at the calculator and possibly choose some things, but just keep in mind that the sign that you see here, it's going to be x minus where you're crossing the x-axis, and then it's going to be x minus where you're crossing the x-axis. Because to get x equals -2, you're going to have x plus 2, right, equals 0. That's when x is equal to -2, like it is here, okay? And so you're bringing the -2 back over to this side to make it as a factor. Same thing here for 4. You're bringing it over to this side. So it's minus a -2 minus a +4. Okay. I don't know if this is all that helpful, but that is another possibility of a way to figure out how to factor something. If it's, if it goes through a nice, goes through the x-axis nicely and cleanly, and you're able to pick those factors up. Okay. Now let's flip over to example 6. All right, so at this point, up to this point, what you've really been doing is figuring out how to factor. But factoring is a technique similar to, analogous to, I guess I should say, using the quadratic formula, where you're solving a quadratic equation. So in example 6, they're saying solve this equation by factoring. So, and they're giving you x squared minus 3x equals 10. All right, so the first thing you want to do is and they want you to do this by factoring, okay? So when you're dealing with quadratics, you always want to move everything onto one side and have it equal to 0. So you're going to subtract 10 to start with on each side. So you get x squared minus 3x minus 10 equals 0, okay? Now, you're going to do what you did before. You're going to factor this. So you're looking for factors of -10 that are going to combine into -3. So that's going to tell you that the larger absolute value is going to be negative and the smaller one's going to be positive. And so you're going to start with 1 and -10. Well, that combines into -9. That doesn't do it. Then you're going to go to +2 and -5. Okay, there's your -10 when you multiply, and your -3 when you combine those, right? So you're going to factor that. So that's x plus 2 times x minus 5. Okay, you're replacing the factored, the two binomial factors in the place of the quadratic trinomial because those are equivalent. All right, now you're going to take what you learned in the prior section, 10.4, about solving quadratics in factored form. This is now in factored form, so you're going to set each of these individual factors to 0 and solve for x. Okay. All right, so what does x equal? So x is going to equal -2, and x is going to equal +5 here. Okay. All right. All right, let's do example 7. All right, example 7. Okay. You are putting a stone border along two sides of a rectangular Japanese garden that measured 6 yards by 15 yards. Okay, so they're giving us some garden here, and they're saying that this is 15 yards, and they're saying that this is 6 yards. Okay. Okay, your budget limits you to only enough stone to cover 46 square yards. How wide should the border be? So what they're saying is they're going to put a certain amount on this side and a certain amount on this side, okay? And they want that to add up. Oops, here. They want this to add up to 46 square yards. Okay, so we're adding an x here, we're adding an x here. So what we want to do, right, so basically the area of the border, yeah, I think this is an easier way to look at it. The area of the border is basically going to be what? It's going to be the area of the whole shebang, right, minus this garden, the 15 by 6 garden, right? So to get the border, get the area of the border, we're gonna take the entire. We're going to take the area, the total area, right, of the whole garden with the border, and we're going to subtract out the garden, okay, the area of the garden. All right. And we want this area of the border to equal that 46 square yards, right? So the area of the border, we want it to be 46 square yards, okay? All right, now what's the total area going to be? Well, what's this dimension here? Right? Well, it's 15, or x plus 15, okay? And then what's this area right here on this side? I mean, this area, I should say, this length. So this length times this length, right? Well, it's going to be x plus 6. All right. Now you're going to FOIL things out, and you're going to move stuff to the other side. So everything equals 0 in the end. All right, so what do we get? We got x squared, right? We're going to FOIL. We're going to get plus 6x plus 15x plus 6 times 15, which I believe is, okay, 90. Okay, and this is equal to 46. All right, now we're going, since this is a quadratic, we're going to have everything on one side, and we're going to simplify. So I'm going to subtract 46 from both sides. Okay, and also I need to combine these middle terms. So I get x squared plus 21x, and then 90 minus 46 is 44. And now this is equal to 0. Okay, so I want to solve for x here, and I'm going to use, since we're learning factoring, we're going to use factoring. So I am looking for factors of 44 that combine into 21. Okay, and they're all positive here. So, wait a minute, what did I do? Oh, wait a minute, this is not right. Oh, yeah, that's right, 44. No, that's right. 90 minus 46, right? Oh, I didn't subtract the garden area. That's why this is messed up. Okay, yes, and I need to set, this is, I did this, I forgot to do this. Minus 90 again. Minus 90. Minus 90. Okay, so this turns out now to be minus 46. Okay, because the two 90s are going to cross out, right? And this is minus 46. Okay. Okay. Yes, I almost forgot that. And I would redo this, except that I already invested so much time doing this, I'm going to just keep going forward. Okay, so this is going to be 21x minus 46. Okay, so we are looking for factors of negative 46 that combine into positive 21. So this is going to tell me that my larger factors or larger absolute values are going to be positive and the smaller ones are going to be negative. All right, so I start 1 and 46, right? Well, what does that combine into? 45. That's not going to do it. Then I do negative 2, and let's see. Okay, 46 divided by 2. Okay, that's 2 and 20. Okay, negative 2 and positive 23. I think we got our combination. Because if I combine those, that will combine to a positive 21. So that's 0 equals x minus 2 times x plus 23. Now I'm going to solve those factors. Set them each equal to 0 and solve. So x minus 2 equals 0. So x equals positive 2. X plus 23, I set that to 0 using the zero product property. And then I get x equals negative 23. Now, in the context of this problem, does it make sense to have a negative dimension for x? It doesn't. While the quadratic itself has a negative answer, it's not applicable in this problem, so we throw it out. And you're going to learn a fancy word in Algebra 2. It's called extraneous. We have an extraneous solution. It means it's algebraically correct, but it doesn't really work in the application of the problem. So we're going to throw that out. But the x equals 2, that does work, and that is going to be our solution that we're going to use for that. All right, let's do the checkpoint, and then we will be done. I think I might do that in another video because this video might be getting long at this point. So come back in the next video after you do the checkpoint.